Right now, somewhere out in space, there is an object so dense that a single teaspoon of it would weigh more than every human being on Earth combined. 1 teaspoon, about 4 billion tons. If you could somehow hold it in your hand, it would punch straight through your skin, through the floor, through the planet, and keep falling until it reached the center of the Earth. This object is called a neutron star. And in the next few minutes, the way you think about reality is going to feel a little bit broken. Because neutron stars do not just bend the rules of physics. They take those rules, twist them into shapes that should not be possible, and then dare the universe to stop them. So let us start at the beginning, with death. Every neutron star begins its life as a giant star, something at least 8 times bigger than our sun. For millions of years, that star does one thing. It fights. Deep in its core, it is smashing atoms together and releasing unbelievable amounts of energy. That energy pushes outward, trying to make the star explode. But gravity is always pulling inward, trying to crush it. And for most of the star's life, these two forces are almost perfectly balanced. But here is the problem. Eventually, the star runs out of fuel. When that happens, the fight is over. There is nothing left to push outward. And gravity, which has been waiting patiently this entire time, finally wins. In less than 1 second, the core of the star collapses. We are talking about something larger than our sun falling in on itself at nearly a quarter of the speed of light. And then the star explodes. This explosion is called a supernova, and for a few weeks it can shine brighter than an entire galaxy of billions of stars. But the explosion is not the interesting part. The interesting part is what it leaves behind. Because in the center of all that chaos, the core has been squeezed so hard that something incredible happens. Now here is a fact that almost nobody really thinks about. Atoms are mostly empty space. If an atom were the size of a football stadium, the actual solid part in the middle, the nucleus, would be about the size of a marble sitting at the center of the field. Everything else is just emptiness. That is true for you, for your phone, for the chair you are sitting in. You are almost entirely made of nothing. But in a collapsing star, gravity is so strong that it crushes that empty space right out of existence. It forces the tiny particles inside every atom to merge together into neutrons, and then it packs those neutrons together so tightly that there is no gap left at all. Imagine taking the entire population of Earth and squeezing every single person into one grain of sand. That is the kind of compression we are talking about. The result is a ball about 20 kilometers wide. That is it, smaller than most cities. But inside that tiny ball is more mass than our entire sun. This is a neutron star. And this is where things really stop making sense. Because a neutron star is so dense that its gravity is absolutely monstrous. If you dropped a single marshmallow onto the surface of a neutron star, it would hit with the energy of an atomic bomb. The gravity is so strong that the tallest mountain on the entire surface would be just a few millimeters high. Anything taller than that gets instantly flattened. The whole star is smoother than a billiard ball. And the gravity does something even stranger than that. It bends light. A neutron star's gravity is so powerful that it actually warps the space around it, which means you can see part of the back of the star curving around the edges at the same time as the front. You are looking at an object and somehow seeing the side that is facing away from you. That should be impossible, but for a neutron star, that is just a normal day. Now let us talk about speed. When a giant star collapses, it does not just get smaller, it gets faster. Think about an ice skater pulling their arms in to spin quicker. The exact same thing happens here, but on an insane scale. A star that used to take a month to rotate once suddenly shrinks down to the size of a city, and when it does, it begins to spin faster and faster and faster. Some neutron stars spin so fast that they complete several hundred full rotations every single second. Let that sink in for a moment. There is a ball heavier than the sun, the size of a city, spinning around hundreds of times per second. The surface of that star is moving at a real fraction of the speed of light. If it spun even a little bit faster, it would rip itself apart. As these stars spin, many of them blast out beams of radiation from their poles like a cosmic lighthouse. And every time one of those beams sweeps past Earth, our telescopes pick up a pulse. Beep, beep, beep. So regular and so precise that when scientists first discovered them back in 1967, they genuinely wondered if they were receiving a signal from an alien civilization. They even nicknamed the very first one little green men. It was not aliens. It was something that is arguably stranger. A dead star, spinning in the dark, screaming out a rhythm more accurate than almost any clock on Earth. But we are not done, because some neutron stars have one more trick, and honestly, it is terrifying. A small number of them have magnetic fields so powerful that we struggle to even describe them. These ones are called magnetars. To give you an idea, a magnetar's magnetic field is trillions of times stronger than the magnetic field of the Earth. If a magnetar were sitting where the moon is right now, it would wipe the data off every credit card on the planet, and it would pull the iron straight out of your blood. And once in a while, a magnetar has what you might call a glitch. Its surface cracks like a starquake, and it releases a sudden burst of energy. Back in 2004, a single burst from a magnetar 50,000 light-years away reached our solar system. It was so powerful that, even after traveling for 50,000 years across space, it still squeezed Earth's magnetic field and disturbed our upper atmosphere. A flash from a dead star, halfway across the galaxy, reached out and touched our planet in a fraction of a second. Oh, and one more thing. You are actually wearing neutron stars right now. When two neutron stars crash into each other, the collision is so violent that it forges the heaviest elements in the universe. Gold, platinum, the gold in a ring, the gold inside your phone, basically every piece of gold that has ever existed, was born in the death crash of two dead stars. You are quite literally decorated with the remains of the most extreme objects in the entire cosmos. So let us step back for a second and really think about what a neutron star actually is. It is the corpse of a star. It is a city-sized ball that is heavier than the sun. It spins hundreds of times a second. It bends light around itself. And some of them carry magnetic fields strong enough to reach across the galaxy and disturb a planet. And here is the part that genuinely keeps me up at night. Nobody actually knows what is at the very center. The pressure in the core of a neutron star is so extreme that our current physics simply runs out of answers. The neutrons might be getting crushed into a strange new kind of matter that does not exist anywhere else in the universe. Scientists have given it names, but the honest truth is, we do not really understand it. There may be a state of matter sitting at the heart of these stars that we have never seen, and might never be able to recreate. Which means, in a very real way, neutron stars are some of the last great mysteries hiding in plain sight. We can see them. We can hear them ticking. We can measure their pull on everything around them. But what they truly are at their core is still unknown. A star burns bright for millions of years. Then it dies in a single second. And what it leaves behind is so extreme, so impossible, that it breaks the very physics that created it. So the next time you look up at the night sky, remember this. Some of those tiny points of light are not really stars at all. They are the ghosts of stars, spinning in the dark, keeping perfect time, waiting for us to finally understand them.